Probability models. All right, probability models, we're using charts again to figure out probability. The table to the right shows the number of students who passed their driving test as whether they took driver's ed or did not. Okay, so what effect, if any, does taking driver's ed class have? So if they took the class, then 32 of the 39 passed the test. If they did not take the class, then 18 of the 41, only 18 of the 41 passed. Okay? So if you took the class, you have a better chance of passing the test than if you didn't, because you have a 32 out of 39 chance versus an 18 out of 41 chance of passing the test. Okay? So we'll get into two-way frequency tables here today. A two-way frequency table talks about two different things in this related to each other in the same table. So you go this way, then the total, just like our professors and our males. Okay? So using a two-way frequency table, the table shows about student involvement in extracurricular activities. What's the probability a randomly chosen student is a female who's not involved in extracurricular activities? The females not involved in extracurricular activities is 120. Out of the total number of students of 516, there's a 23.3% chance that if you grab a student at random, they're a female who is not involved in activities. So here's a two-way frequency table of males and females that are on the prom committee. So there's 12 total students that are on the prom committee. What's the probability a member of the prom committee is male and a junior? Junior males are 3 of the 12, which is 1/4. Okay? Now, with these two-way frequency tables, we can have conditional probability. Conditional probability is the probability that an event will occur given another event has already occurred. Okay? So you can write a conditional probability of event B given event A has already occurred. Probability of B given event A. Probability of B given event A. So if we look at this, opinion polls. Respondents to a poll were asked whether they'd vote for, against, or had no opinion about a bill before the state legislature that would increase the minimum wage. What's the probability that a randomly selected person is over 60 years old, given the person had no opinion on the bill? So, out of the no opinions on the bill, what's the probability that they were over? What's the probability that they're over 60 years old? So we're just looking at this part of the chart. Given that they had no opinion, what's the probability that they're over 60? Well, that's 40 of the 100 people, or 40% of the 40%. Okay? So if we look at this, what's the probability a randomly selected person is between 30 and 45, given that they're in favor of the bill? If they're in favor of the bill as these, so that's 200 out of 780, which is 20 out of 78, which is 10 out of 39. Okay? So that's using a two-way frequency table. Okay? Relative frequencies is already percent inside, so it should add up to 100%. So this is 48%, 2%, 32%, 18%, and you add to get 100%. So a company has 150 sales representatives. 2 months after their sales seminar, the company vice president made a table of relative frequency based on sales results. What's the probability that someone who attended this seminar has an increase of sales. Okay? So the increased sales were 48% of the people who attended the seminar. Okay? And then 2% of the people who didn't attend the seminar. Okay? So you take 48% of the 150 people working there, which is 72 people. Okay? Find the people who attended the seminar. Well, that's 80% of the 150 people that worked there, or 120. So if you take the 72 divided by 120, or what would be easier for me, take 0.48 divided by 0.8 of the people who attended the seminar, how many had increased in sales? That would be 60%. Okay? All right. So let's go to what we'll see on the assignment. All right. Now, what you do is you look at this first, because it's this depending on this. So you look at the ones that support the issue. Of those that supported the issue, how many were Democrats? Of the people that support the issue, how many were Democrats? Well, of the 58 people, 23 were Democrats. It says, type an integer or a decimal round to the nearest hundredth. So you divide these. Somebody with a calculator, what's 23 divided by 58? What? 0.40, which is 40%. All right. Now, see how this had a line and two things here. If there's no line, then you had to take the total out of everybody. Okay, out of everybody. So what's the probability that there's a 7th grade boy in that chart? Well, a 7th grade boy is right here. Out of everybody is here. So it'd be 6 out of 50, which reduces down to 3 over 25. Philip. Yeah. Okay. Yep. Miles. Yeah. What? To the office. Right now? Yeah. Leave your stuff. You'll come back, so you're not in too big of trouble. I hope. Okay? Now, this didn't have a line, so it's out of the total. This has a line right here, attended college liberal. So out of those who attended college, how many are liberal? Okay? So you take the 15 plus 11 is 26, plus 27 is 53. Of those, so 53 attended college, 15 are liberal, so you go 15 out of 53. Okay? The frequency table, given that the randomly chosen animal is a dog. Oh, what's the probability the randomly chosen animal is a dog given the treatment with shots only? So we're looking at shots only. We want to do the dogs out of the shots only. So it's 0.35 out of 0.70, which is 1/2, or 0.5. Okay, 50% of them. Last one, probability of freshmen. Since there's no line here, what do? Take it out of the total. Probability of a freshman, well, freshmen are all these over here, so 8 out of the 48. 8 out of 48, which reduces down to 1/6. Okay? You're going to have a whopping 5-problem assignment today, so you should get done in a reasonable amount of time, and then after lunch, you'll have time to work on other stuff that you're behind on.